Hi class. With this video, we begin the discussion on related rates applications. I think with the example 1, starting on page 63 of your note packet. Before we work any examples, I sort of want to give you a rough idea of what this is all about, what this material is all about. Earlier in the semester, right, we have worked with demand equations. When we did elasticity of demand on exam 1, right, we worked with a demand equation, finding the elasticity of demand. And then the material on marginal economics, revenue functions, profit functions. We worked with demand equations, right, to find the revenue function and then the profit function. So to demonstrate what's going on here, I have a demand equation, x equals 10 minus 0.2 times p, okay? P is the price of the good, right, per unit, and x is the amount of the good sold, okay, at each price p, and x is measured in thousands. T, right, there's the 3 variables with related rates, right, we deal with 3 variables now. T is time, okay? And so we're going to be, in solving related rates application problems, okay, we're going to be using implicit differentiation from the previous pages, and it's going to be applied, that implicit differentiation is going to be applied to these related rates applications, okay? So in our demand equation, right, I have a table over here. Imagine that in the first week of selling this good, we charge a price of $5 per unit, which means we sell x is equal to 9, or 9,000 units. In week 2, we raise the price to $5.50, and we sell 8.9 thousand units, or 8,900. And in the third week, we raise the price to $6 per unit, and we sell 8.8 thousand units, or 8,800. Okay, so our combinations of price and quantity, P and X, always satisfy the demand equation up here, right? The demand equation tells us how much we're going to sell at each price P. But what I want you to see here is there's like a third dimension to this problem, okay? Across time, from week 1 to week 2 to week 3, right, the price is changing. And so the price changes as time changes. And we measure the change in price as time changes with the derivative, dp over dt. So we got the derivative of the price p with respect to time. As time changes, the price changes. And the same is true with the quantity demanded, okay? As we go from week 1 to week 2 to week 3, the quantity sold is changing, okay? And so quantity sold is changing with time. And so we measure that rate of change of the quantity sold as time changes with the derivative dx over dt, right? The rate of change of x, the derivative of x with respect to t. So in solving problems involving, in solving these related rates application problems, we're going to be dealing with 3 variables, four variables, 4 quantities. xp, the rate of change of x with respect to time, and the rate of change of price with respect to time. And so we'll be given 3 pieces of information, and we'll have to figure out the 4th piece using implicit differentiation, okay? And so that's where we're headed in this, with this material.